So first of all, IPv6 address. So IPv6 address size is 128 bits. So these 128 bits are written in the form of 8 hextets. So one hextet, one portion of 16 bits. So 16 bits portion is called as hextet. And these hextets are separated by colon. So in IPv4, so we write down IPv4 address in the form of 4 octets, which are separated by dot. So here separator is colon. So we can write down 128 bits in the form of 8 hextets, 8 portions of 16 bits. So hexadecimal number, when we say 16 bits, it means 4 hexadecimal number. So separated by colon. So let's write down an address 2001 colon ACAD colon 0DB8 colon 001 colon 000 colon 000 colon 000 colon 0001. So these are 8 portions of 4 hexadecimal numbers separated by colon. So the IPv6 address can be divided into 2 parts. Like in IPv4, IPv4 address can be divided into 2 parts. So similarly, IPv6 address can be divided into 2 parts. Let's say this is your address. So we can divide it into 2 parts of 64 bits. The first 64-bit portion is called as prefix. So this is your prefix, and prefix size is 64 bits. The second portion is called as interface ID. It is something like the host portion. Prefix is the network portion. Interface ID is the host portion. Again, interface ID size is also 64 bits. So when we write down an IPv6 address, so we can specify slash and then slash value. Slash value represents the prefix length. What is the size of the prefix? So we have already specified along with prefix that prefix is 64 bits. But if you do not writing it something like this and you just want to write down an IPv6 address, so then you can put it like this /64. So in this way, so an IPv6 address has a prefix, interface ID, and prefix length. So IPv6 address is a lengthy address. So we can simplify it by using 2 rules. It can be shortened or simplified by using 2 rules. The first rule is omit the leading zeros. Omit the leading zeros. So what are the leading zeros? So let's say this is our IP address. So this one is leading 0. So I'm going to change the color of these leading zeros. So here in this section, we have 3 leading zeros. Again in this section, we have 3 leading zeros. 3 leading 0. 3 leading zeros. Again 3 leading zeros. So these are the leading zeros. If we omit this, the address will look like something like this. So 2001 colon ACAD colon DB8 colon 1 colon 0 colon 0 colon 0 colon 1. So now it looks like a little bit short address or shorter address, shorter than the actual IPv6 address. So this is, we have just applied one rule. The second rule says that you can omit all zeros hexed by putting double colon. It means you just remove the zeros and both columns will come close to each other. So omit all zeros hexed by putting double colon. But there is a precaution that this double colon can be used one time per address. So you cannot use it twice in an address. It can be used once in an address. So it is your choice. Let's say if you have uh, uh so okay, let me add another sentence and then we will discuss it. If we have one all zeros hexed or multiple consecutive all zeros hexed, so we can omit all by using a single double colon. So let's say we have three consecutive all zero hexed. So what we will do is when we omit these, we can write down it is something like this: 2001 colon ACAD colon DB8 colon 1 double colon 1. So in this way, this address is more shortened or more simplified. So these are the two rules which you can use to simplify this lengthy IPv6 address. So now we will discuss the IPv6 message types. So in IPv4 we were having three message types. The first one was unicast. The first one is unicast. So here it is same unicast. So unicast, one sender, one receiver. So one-to-one communication is called as unicast. Multicast. So multicast is one to a group. So the third one was broadcast. So there is no concept of broadcast in IPv6. So instead of broadcast, we are using Anycast. So Anycast is one to one of the group. So one to one of the group means, let's say when we say multicast, so one server is sending to all users. So your users are in groups. Server is one. But when we say Anycast, servers are in group. So user can access any one of the servers in the group. It does not need to go to all, or it doesn't need to connect to all servers in the group. It is something like that. You reach to some cinema hall. There were 5 to 6 windows from where you can get your buy your ticket. So now you will look for the less congested window, and just you will become the part of that line. And what will happen is, there when your turn will come, you will get your service, you will buy your ticket. So you don't need to go to other windows. So you just need to contact one of the group members. In the same way, let's say if you are in US and you write down google.com, so it will take you to google.com. If you are in UK, google.co.uk. If you are in Thailand, google.th. So it is just something like an example, just to understand whichever is your closest service point. So you are directed towards that closest service point. So you do not need to contact all group members. You just have to contact one of the group members. So this thing is called as Anycast, any of the group member. So now we will discuss the IPv6 address types. So IPv6 address types, the first one is called as unspecified address. So this unspecified address in IPv4 is 0.0.0. So it is same here. If your all hexadecimal numbers are 0, it means all bits are 0. So 1234 colon 1234 colon 1234 colon 1234. So colon and paste. So this is your all 0. This is your unspecified address. If we apply the first rule, it will look like something like this: 0 colon 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros. So second rule, if there is one all zeros exit or multiple consecutive all zeros exit, so you can just put double colon. So we do not need to put anything else, you just put double colon. So this double colon /0. So this is your unspecified address. If you have to define the default route, so you will use this address, double colon /0. Then we have a second type of address that is called as loopback address. In IPv4, your loopback address is 127.001 for the local host. So in IPv6, the loopback address is 0000. The last one is 1. So this one will become 1. So it will become double colon 1 /128. So this is your loopback address. So unspecified address, loopback address. Then like IPv4, in IPv4, class A, class B, class C. So those three classes represents the unicast addresses. So class D represents the multicast. So in the similar way, in IPv6, the third type of the address are called the unicast addresses. So unicast addresses. So when we say unicast addresses, so there are multiple types of unicast addresses. So the first type of the unicast address is called as global unicast address. So this global unicast address, you can compare it with public IP in IPv4. If you want to communicate over the internet, you need this address. So addresses starting with 200, double colon /3. So this is the range for the global unicast address. So what are the IP addresses covered in this range? So to have a look for that, we have to write down the binary of this 2000. So 2 is a hexadecimal number. It means 8 is 0, 4 is 0, 2 is 1, and 1 is 0. So 3 bits are fixed. That's why I'm going to separate this fourth bit. And then the next one is 0. So 1, 2, 3, 4, 4, 0. 1, 2, 3, 4, 4, 0. 1, 2, 3, 4, 4, 0. If we keep 0, 0, 1 as fixed and we change the rest of the values to 1. So this one is your 2000. So from 2000 to 3FFF. So all these addresses starting with 2 and 3 are public or global. So whenever you have to communicate over the internet, you need one global unicast address. And all the addresses starting with 2 and 3. So these are your global unicast addresses. So when we say global unicast addresses, let's say we have a global unicast address 2001 colon ACAD colon DB8 colon 1 double colon 1 and slash 64. So this is your global unicast address, example of the global unicast address. So this global unicast address can be divided, further subdivided into different portions. The first portion is called as global routing prefix. So this global routing prefix is 48 bits. So first 48 bits is your global routing prefix. So network portion or prefix is 64 bits. But right now we are just talking about 48 bits. So first 48 bits, so these first 48 bits are called as global routing prefix. Then after this, the next 16 bit is called as subnet ID. Let's say one ISP is given one global routing prefix for its customers. It can further create different subnets. So in 16 bits, we have 65536 subnets options available. So for one ISP, one global routing prefix is more than enough. Then the next one is your double column one is your interface ID. Interface ID is your client or host part. And slash 64 is your prefix length. So this is how we can divide a global unicast address into different portions or different parts. Then we have a second type of address, unicast address. So we'll write it as B, and it is called as unique local unicast address. So you can compare this unique local unicast address with the private IP. So if you have multiple VLANs or you have divided your network into multiple private networks, so you can go for this unique local address. The range for the unique local address is FC00 double colon slash 7. So first 7 bits are fixed. So if we want to see what are those 7 bits, so we can write down in the binary. F means 111. So this is your F. C is 12. A is 10. B is 11. C is 12. So 12 is 8 plus 4. And then 2 is 0. So these are 7 bits. The next one is also 0. But that bit is not fixed. And after that you have 2 times 0. So 0, 0, 0. This is first 0. 0, 0, 0. This is the second 0. So if we want to write down it as FC00 and we say double colon slash 7. So 7 bits are fixed. So these 7 bits are fixed, but this bit, so this bit is reserved. Reserved means you cannot use. So when we cannot use, so we can say this FC00 is a reserved IPv6 address. So we cannot use it. So when we have to use it, we just convert it, make it to FD00. So when we make it FD00, this is not reserved, we can make it 1. So when we make it 1, so now it becomes 13. 13 is FD. So FD00 double colon slash 7. So we can use all the addresses starting with FD00 double as the unique local addresses or private addresses. After this, we have another type of unicast address, and that is called as link local address or link local unicast address. So link local unicast address is starting with FE80 double colon slash 10. So this range is reserved for link local. You can compare it with APIPA in IPv4, but again, the role of APIPA in IPv4 is only to communicate with DHCP server. So in case of IPv6, so there is no any such requirement that we have to only communicate with DHCP server. All the communication happening on the local subnet is based on this link local unicast address. Let's say you have some shared folder and you want to access it within the subnet, so you can use link local address. If you want to get a print, link local. If two routers wants to establish neighbor relationship, so they can use link local to establish the routing protocol neighbor relationship. So all the communications happening on the local subnet, so that can be or that is based on the link local address. So FE80 double colon 10. So we have to look for those 10 bits which are fixed. So F means 15. So 1, 2, 3, 4. E means E means 14. So 1 less. So 1, 1, 1, 0. After this 8, 1, 0. So these are 10 bits which are fixed. Then we have two more bits here and 0, 0, 0. So we can write it down as FE80 double colon. So all the addresses started with FE80. The next possibility is these are 1, these three are 1, 0, the next one is 1, 0. These are fixed. We can change it to 0, 1. So when we change it to 0, 1, so this address will become FE90 double colon. If we keep it 1, 1, 1 and we 1, 1, 0, 1, 0, so these are fixed bits. If we change these to 1, 0, so then it becomes FEA0. So 1, 1, 1, 1, 1, 0. So 1, 0 is fixed. If we make these two bits as 1, 1. So this one becomes FEB0. So all the addresses starting with FE80, FE90, FEA0, FEB0. So these are the link local addresses because the first 10 bits are same in all these addresses. So these are your unicast addresses. These three types of addresses are called as IPv6 unicast address. So then we have another type of address which is called as multicast. So all the addresses starting with FF00 double colon /8. So in the first two hexadecimal number, we want to see FF. So then this range, all the addresses starting with FF, so these are called as multicast addresses in IPv6. So again, we have different types of well-known addresses. Let's say FF02. FF02, these are the addresses which are called as local subnet scope well-known addresses. So FF02. And if we put double colon 1, so it is equals to 224.0.0.1 in IPv4. So all hosts on a subnet. So in the same way, we can have FF02 double colon 2. All routers on a subnet. So 224.0.0.5 all OSPF routers. So FF02 double colon 5. So in this way, these are the multicast addresses. So we have just discussed that right now Anycast addresses, if you assign the same unicast address to multiple devices, so that address becomes the Anycast IP. There is no any specific range for those IP addresses. So now we discuss the interface ID. So whatever we have discussed up till now, so that was related to your prefix. So now we discuss what is interface ID. So the last 64 bits of the IPv6 address is called as interface ID. So, or you can call it as host portion of the IPv6 address. So host portion of the IPv6 address is called as interface ID. So we have different options available. The first one is called as static interface IDs. Static interface ID can be configured with the static IPv6 address configuration. So you can use any values of 64-bit. So any value of 64 bits can be used as interface ID. Let's say if you are doing the dual stacking means you have configured IPv4 and you want to enable IPv6 on the same network. So you are using 192.168.1.0 network and your router is 192.168.1.1. So if you convert the IP into IPv6 address, so you can use the same host portion .1 instead of .1. So any value of 64 bits can be used as interface ID. Let's say our network is 2001 and then ACAD DB8 1, and then we can just put :1 and /64. So this :1 we have used as the interface ID. So we can use any 64-bit value as the interface ID when we configure the static IPv6 address. So we have different options available. So now what we'll do is, in the next step, the second step is we can use EUI/64 interface ID. EUI64 extended unique identifier. So this extended. So your unique identifier is your MAC address. Extended unique identifier. So and it is extended to 64 bits. So our unique identifier is MAC address, and the size of the MAC address is 48 bits. In IPv6, interface ID is 64 bits. So we can extend 48 bits MAC address to 64 bits interface ID in two-step process. So the first step, so we have to separate OUI and vendor assigned portions of the MAC address. And insert FFFE. Let's say we have a MAC address 000.111.222. So this is 48 bits MAC address. So we want to generate 64-bit interface ID. So what we'll do, we will separate the OUI and vendor assigned portions. So first 24 bits is your OUI, organizational unique identifier, and the last 24 bits is called as vendor assigned, which is the serial number of the devices. So now what we'll do is, in the next step, we have separated it. So we have to insert FFFE. So when we insert FFFE, so we have to make 4 exits because your interface ID is 4 exits. So 000, and those exits are separated by colon. So colon 11 FF, colon FE 11, colon 222. So in this way, we have converted 48-bit MAC address to 64-bit interface ID, but one step is still pending. So the second step, invert the 7th bit. If your 7th bit is 1, make it 0. If it is 0, make it 1. So which one is the 7th bit? So we have to find out the 7th bit in this first sextet. So if we will write down this sextet into binary, so first 0, 1, 2, 3, 4. The second 0, 1, 2, 3, 4. Third 0, 1, 2, 3, 4. Fourth 0, 1, 2, 3, 4. So we have to look for the 7th bit. So 4, 5, 6, 7. So this one is the 7th bit. So we have to invert it. So 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0. So we have inverted it to 1. So when it is inverted to 1, now we can write it as 0200. And if we will add the remaining part of the interface ID here, so now it becomes your proper interface ID. If you omit the leading 0, you can make it 200 colon 11 ff colon fe 11 colon 222. So now this is your EUI slash or dash 64 interface ID. And how we have generated? By using the 48 bits MAC address. The third possibility. So first possibility was you can use static interface ID. The second possibility is you can use EUI slash 64 interface ID. And the third possibility is randomly generated interface IDs. So randomly generated interface ID. So when we get the IPv6 address from the DHCP server, so when we get the IPv6 address from the DHCPv6 server, so it assigns a randomly generated interface ID. So when we get the IPv6 address from DHCPv6 server, so DHCPv6 assigns randomly generated interface IDs. So these are three possibilities that how we can get the interface ID. So now we will see how we can configure or we can assign the IPv6 addresses on the router on the PCs. So first of all, uh, just give me 1 minute to bring a glass of water. Then we will start the configuration steps. So IPv6 address configuration. The first possibility is we can configure the static IPv6 address. Let's say we have a router, a switch, some end hosts, and one server. So we connect all these devices with a switch. Let's say our IPv4 network is 192.168.1.0. I'm quickly configure the addresses here. So 192.168.1.10 and the gateway is 192.168.1.1. So this is server, make it 100. Clients we will keep 10, 11. So we go here and we say 192.168.1.10. So gateway is 192.168.1.1. So 192.168.1.11 to 192.168.1. So 192.168.1.12. So 192.168.1.1. So let's quickly configure the router. So enable global configuration mode, host name is R1, interface is fast Ethernet 0x0, IP address is 192.168.1.1, 255.255.255.0, and then we say no shut. So we have configured IPv4 addresses. I'm going to use the same subnet by converting it to an IPv6 address. So 2001 colon 192 colon 168 colon 1 double colon /64. So this is your network ID. So when the host portion bits are 0, so that is called as network ID. So this is your network ID. So from this network, on this device we can use double colon 100. On this device we can use double colon 10. So double colon 11, 12, 1. So we want to configure these addresses. We can configure like these addresses, but I will just configure static on one server or maybe on two devices. On the rest of the devices, we will discuss other options. So let's say we want to configure the static IP for this server first. So we go here. Here we will say 2001, 192, 168, 1 double colon 100. So slash value is 64, and here we have to define the gateway. So FE80 double colon 1. So this we will use this FE80 double colon 1 as a link local of the router. So that's why I'm using it in the gateway. This maybe you have to verify the connectivity with this server. So this lengthy address cannot be memorized. So if you want to ping to this address, it will become very difficult. So that's why I'm going to change it to 100. So in this way, we have assigned the static global and static link local address. So on PC or server, we can use this option. We have mesh/64. If we configure on router, so for the router we need to remember one very important thing. So that is your IPv6 routing is not enabled by default. So in Cisco iOS, so IPv6 unicast routing is not enabled by default. So whenever you have to configure a router and you want to perform that router to be involved in routing of IPv6 addresses, so then what you will do is you will go to the router and then use the command IPv6 unicast routing. So this command will enable unicast routing on the router. So after enabling this IPv6 routing, we have to configure two addresses. The first address is global. So we go to interface fast Ethernet 0 by 0. So IPv6 address and then we say 2001.192.168 and the IP address is 1.1, so we will make it 1:1/64. So in this way we can configure the global unicast address, static global unicast address and IPv6 address FE80:1 link local. So we can configure the link local address as well. And exit. So this is your interface configuration or static IPv6 configuration on the router. So global address and static link local address. So this is how we can enable or we can configure the static addresses on the routers. So now we'll discuss the dynamic IPv6 address configuration options. The first option is called as SLAAC, stateless address auto configuration. So stateless address auto configuration. So IPv6 has a sub protocol NDP, Neighbor Discovery Protocol. So this protocol offers the router discovery and neighbor discovery. So it also helps in implementation of IPv6 redirect or some service redirect. So SLAAC uses the router discovery process of NDP, Neighbor Discovery Protocol. So for router discovery, we have two messages. The first one is router solicitation message. And the second one is router advertisement message. In short, this message is called as RS. This is called as RA. RS message is multicast. Multi is sent on multicast address FF02:2 all routers on a subnet. RA message is sent to a multicast address FF02:1 all hosts on a subnet. Let's say we have a PC and a router. On the router, we have completed this configuration. Means your unicast routing has to be enabled, and you must have to configure at least one global unicast address on the interface. So now what will happen is this client will send a router solicitation message. Multicasted on FF02:2. So when this message is received to the router, so router will respond with RA message. So router advertisement message we receive in response of that router solicitation message. So this message carries the prefix, prefix length, and gateway IP. So prefix prefix length and gateway IP. So this information it will be carried. It carries. So when this host gets the prefix, so it generates its EUI/64 interface ID. To complete the IPv6 address. So let's say we go to this PC. We click on automatic. So routers will keep that message, other devices will discard it. So now the router is sending an advertisement. So source IP FE80:1, destination IP FS021, all hosts on a subnet. So here you can see that this is router advertisement message. If you scroll down, you can see prefix length 64. So this is your prefix and this is your gateway IP. And you can see it uses the EUI/64 interface ID and the prefix received, prefix length received, and the gateway IP received. So this thing is called as SLAAC, router solicitation, router advertisement. The second method is called as SLAAC plus stateless DHCPv6. So what is the difference between stateful and stateless? Anyone can tell? ACL. So when a packet comes, if it matches the access control list condition, it is and the action is permit, so it is allowed to go. But ACL does not keep the record which packet is or which packets are gone through the router. It is not storing the information anywhere. But if we are talking about the firewall, so when the traffic will go outside of the network, firewall store the information in the state table. So ACL is stateless, firewall is stateful. In the same way, if someone asks you for a path, let's say you are some manager or something like that, in a company and someone contacts you and he gets some information about some timing. So you do not keep that information or you do not note that information if someone asks about some specific time information. But if someone will come and apply for the job, you will note down. So this guy came and we interviewed him. So that information is stored somewhere so that you can follow up. So now the thing is, the first case someone asked for information, you provided, and you are not keeping that information that who asked you for that information. In the same way, if someone asks you and you note that this guy asked this information and this information I have provided to him, so that is straightforward. In the same way, if we get a complete IPv6 address from the DHCP server, so that is called as stateful DHCPv6 server. But if we are not getting the complete IPv6 address, or even we are not getting the uh, IPv6 address, we just need to know the options information, options DNS server, options. So basically, domain name. So whatever the options information is on IPv4, that is also available in IPv6. If you are using some DHCPv6 server not to assign IPv6 addresses, just to provide the options information, so that is called as stateless DHCPv6. So for stateless DHCPv6, so SLAAC is used to get the prefix, prefix length, and gateway IP. So DHCPv6 can be configured options information like DNS server. So first step will remain the same, whatever we have discussed and seen here. So this part is as it is. For the second part, we need to configure the DHCPv6 on the router. To enable global configuration mode, we will say IPv6 DHCP pool. And here we'll say DNS server is 2001 colon 192 colon 168 colon. So this is the DNS server IP. We are not configuring anything else. We just want to provide some options information. Now we go to interface. Fast system 0 by 0. Here we will say IPv6 DHCP server enable and pool name. Pool name is LAN. IPv6 DHCP server LAN. And then we will use another command IPv6 neighbor discovery other config flag. Other config flag only provide the config other options information. There is no need to provide the IPv6 address. So IPv6 DHCP server, we have enabled the DHCP, we have enabled the scope, and then we have configured that. But we have to get the other config flag information from the DHCP server. So now we will go to the client PC again, static, and again we click on automatic. So you can see it gets DNS address as well. So it gets the prefix length and gateway IP from the SLAAC, and this DNS server address from the DHCP server. So this is called as SLAAC plus stateless DHCPv6. Next option is stateful DHCPv6. So IPv6 address, so prefix length, gateway IP, options information are assigned by DHCPv6. So this configuration is required as it is. So now we have to configure the DHCP. So IPv6, so address prefix, so this is the address prefix. So DNS server, so we have configured address prefix and then we have configured the DNS server. So now we go to interface, and here we will say IPv6. We have already used this command. And we use another command IPv6 ND manage config flag. So manage config flag means you have to get complete IPv6 address information from the DHCP server. So this is your address prefix, this is your DNS server, and then we have enabled it with manage config flag. So we go to any of these PCs, automatic. So now you can see a very lengthy address is assigned. So, but you can see this is not the EUI64. So this was your EUI64. This is not your EUI64. So in this way, we can assign the IPv6 addresses to different devices. So now we have to discuss 2 to 3 things more about IPv6. The first thing is neighbor discovery protocol. First of all, we need to discuss that what is the neighbor discovery process and why we need the neighbor discovery process. Instead of ARP, we are using NDP, neighbor discovery protocol. So why we were using ARP? So first of all, if we need to get a MAC address against some IP address, so we can get it through ARP. Then another possibility is we are using ARP for duplicate address detection. So in the same way, so here we are using NDP for same those purposes. So we have just discussed that there are two main functionalities or three main functionalities of NDP. The first one is router discovery. So we have just seen what is the router discovery. Now we'll see the neighbor discovery. So neighbor discovery is used to get the MAC address. So neighbor discovery is used to get the MAC address of destination IP or of IPv6 address. So neighbor discovery duplicate address detection. So these are both functionalities which in IPv4 we were getting from ARP. To understand the neighbor discovery process, first of all we need to understand the solicited node multicast address. So what is solicited node multicast address? If we go to the router, and here we use show IPv6 interface fast Ethernet 0x0. So this device joined the following groups. So it is a host on a network. That's why it is FF02 double colon 1. It is a router on the subnet FF02 double colon 2. DHCP is running FF02 double colon 1 colon 2. And this the last one is the solicited node multicast address. Let's say so this is our address. So this is the prefix for the solicited node multicast address, and it is /104. So FF02 double colon 1 colon FF/104. So size is 128. So 104 is these bits. So we get the last 24 bits. So we get the last 24 bits of the IPv6 address. If a router is configured with, if a router interface is configured with multiple IP addresses, for each IP we will have a solicited node multicast address. So we get the last 24 bits of the IPv6 address to complete the like our IP address is 2001. So this is our prefix. So 000. So this is the IPv6 address of fast Ethernet 0x0. So we already get these 104 bits, and then add the last 24 bits as it is. So FF02 double colon 1. So I just get the first 104 bit as it is and the last 24 bits. So 16 plus 8. So these are your last 24. So whenever someone or some device wants to send the neighbor discovery message for this IP address 201.192.168.1 double colon 1. So in the same way, we can calculate the solicited node multicast MAC address. So 333 is the first 16 bits of the MAC address. Then we have to use the last 24 bits. Sorry, last 32 bits. So 24 bits are used to get the solicited node multicast address, and now we have to get the solicited node multicast MAC address. So the last 32 bits, okay, let me write down here. So 333 is used as the first 16 bits. And the last 32 bits of the solicited node address used to complete the MAC address.
Sorry, Sakib, I've not understood the use of solicited node multicast address.
As we said that there is no concept of broadcast in IPv6. Let's say if I want to communicate with this router, I do not have the MAC address. There is no concept of ARP. So instead of ARP, we are using neighbor discovery process. As we discuss here, neighbor discovery process.
Yes.
So this neighbor discovery process is used to get the MAC address of IPv6 address, and neighbor discovery process is used for duplicate address detection. So this message is sent on this address.
Okay.
So if we are talking about the solicited node multicast address, and in the Ethernet we will use the solicited node multicast MAC address.
Okay. So that is a responder
address. Yeah.
Okay.
So who will receive only that node for which we are sending it, or if there will be maybe there is some overlap in some IPv6 addresses, there is possibility, but there are very less chances for that. So now we go here on this topology, we go to simulation mode. These are already enabled. So we are using DHCPv6 to get So now you can see it has generated a packet. So you can see 333 FF141733. So this is the MAC address. So in the same way, you can see it here. This is the solicited node address, FF02 double colon 1 colon FF. It is performing duplicate address detection, that I'm gonna offer some address, whether this address is used anywhere or not in the network or not. So now this message will be sent. So if some device will have that IPv6 address, then it will match with that. So NDP is matches with this one. So this is because we have sent this, it matches to its MAC address. So now it is sent back. So it gets that address. So this was the MAC address. So this machine gets this address. So in the same way, if we want to communicate with router, and we say ping 2001.192.168.1 double colon 1. So 0333 FF00001. So if you have a look on the paint file, for this address we have calculated this MAC address 333 FF00001. So we can see it here, 333 FF00001. And then we are sending it to destination IP. This is the solicited node multicast address. And you can see this is that solicited node multicast address. So now this NDP message will be sent. So this device belongs to that multicast group. That's why it matches. So inbound PDU. So 333 FF00001. And this is the solicited node address. It matches here. And now it will send the response back. And it will be carrying the link layer address of 2001.192.168.1.1. So just to reduce the scope of communication, so extra devices do not process or keep on processing the packets. So that's why the destination address is solicited node. So that is not some broadcast IP or something like that. So now we get the information. Now we can send the ICMPv6 to ping. So now we can ping. So solicited node multicast address is used to send the neighbor discovery message for the neighbor discovery process. If you are, whether you are performing duplicate address detection or whether you want to get the MAC address. And it is calculated from this address for which you are sending the duplicate address detection or neighbor discovery request. So for the destinations, we calculate this one, the solicited node address. If you want to see these addresses, you can just go to the router and use show IPv6 interface name and ID. So here it will tell you which are the joined groups. So which groups? Multicast groups. So all hosts on a subnet, all routers on a subnet, DHCP, and this is that solicited node because we are using FE80 double colon 1. So link local address is also double colon 1. So global is also double colon 1. So that's why it belongs to this solicited node address. if we have some different IP address or different interface ID for the so if we are using a different global unicast address and we are using different link local address, so this interface ID is different. So then you will see we are part of the two different groups. Let me change it quickly. So interface fashion 0 by 0. So IPv6 address FE80 :2 link local. Show IPv6 interface fashion 0 by 0. So now it belongs to two different groups because link local address and global address are two different addresses. So neighbor discovery protocol, neighbor discovery process is used to get the MAC address or to resolve the IPv6 address to the MAC address. And the second reason is to perform the duplicate address detection. So we will keep up to here today. If you have any questions, you can ask now. In the next lecture, we will start some routing basics. And after that, we will build the topology for the static routing, not static routing. We will use the same topology for static OSPF EIGR.